Okay, hello everyone. Thank you for coming to this talk. So I would like to talk about Eclipse IoT as well. So we heard already a little bit about it. I want to show you all the things in there from a different angle. I'm from Bosch, and so we have like IoT is a big problem for us, or a big opportunity. But it means that you have to, because we are producing a lot of devices. So for us it's a natural thing that we care about it. In particular, we are really interested in the automotive area, and so it was like a real car was a little bit too heavy to bring it here, so we also reduced it, so like something could be like done also by like everyone. So there is a rover that is done from Eclipse, and this little rover is just like this size. Actually, I was also too lazy to bring it here, or like in the plane it was a little bit a problem. So, and with this rover you can actually drive forward, backward, and things like that. And connecting this thing to a cloud is like the basic idea of Eclipse Cuxa. And you have like three parts, or that's the cloud platform that you need. So Benjamin has already talked about like things that are available here. Most of these are Eclipse IoT components. And then you need something in the car. Typically, Java is not that liked in the car. So that's the reason why we use here automotive grade Linux, which is running without Java. And then of course you need some development environment to do some stuff, and for that we used Eclipse J with Eclipse. And so what we will see in the demo, I've just put together a small video. You will see first the rover. There's a camera drive around it. Then you will see how to build something with Eclipse J, and there it's about adjusted cruise control, meaning that like a car is just making sure that the distance to the front car is hopefully always the same. So when there's something that is faster than the car can move, it will try to make it like again the same distance. So that will be deployed on the car, and then we will see that the adjusting cruise control does work. Afterwards we will just see, and then you can also steer it over the cloud, so you can do forwards, backwards, and things like that. What you have to imagine is, actually that is like a prototype to play with, but it's about much more. It's about, at the end, what like the companies need is that they are able to connect 1 million cars, 1 million devices, or at least a few thousand. And like the entire stack here, for a company like ours, it's about, how to manage thousands and millions of devices. And so everything must scale. On the other hand, it must be easy to learn, easy to get familiar with. So it must be good for like everyone. So easy to start with, but still capable of doing these huge things. And it's also, you can imagine that like a lot of things, like the number of messages coming into something like that is really big. So when you have like thousands and millions of devices connected, it's really like a lot of traffic going in, and then you also need to have maybe a lot of different applications using the different things from the background. So you have one device, and you have maybe 50 applications behind it using it. Or you have like 10 different devices, and one application wants to have like data and control over these 10 devices. So you have a lot of problems that you don't have in an easy setup. And in the future, it looks like that, I will talk a little bit more about it later on, that we will have more and more cross-vendor, cross-domain use cases in IoT, which makes it all a little bit more complicated. And cross-domain, cross-vendor also means, to get that work, everyone needs to collaborate, right? And that means, where is a good model to do that? Of course, open source. So that's the reason why here Eclipse IoT is the thing. So I will show the small demo just to illustrate what you can do. and then we will see a little bit more about it. Hopefully you can see, yeah, that's good. So that is Eclipse J. Oh, sorry, that was in the middle of it. So that's the rover. It's you can see cook size on it. And there are cameras in the front and in the back. And there are some more sensors. Actually, we are thinking about even adding some more stuff. And that's Eclipse J. So the development and getting the stuff then on the rover and to ride it is there. So we will see that we find the adjusted cruise control variable in there. There it is. And now we can do the configuration. The build. Of course, you can do now lots of different things with all that. So it's just one example setup, but it illustrates the idea. And then you can deploy and run that. Of course, I will talk a little bit more about it. That is when you have one car. So that's just a cruise control. Like the robot always tries to get the distance again. And now you see okay, now it's the feed from the telemetry. You can see here you can also steer it. Like here's the steering controls, here's the telemetry data, and here's the event console. And here you can see what the rover is doing actually. So, and now you can also see the camera feed. So, what is important to understand is, for example, you can also use this now for trying to implement something with automated driving. That is one of the areas that would be really nice. If the vehicle is moving really slow, you can actually do everything in the cloud. So you just connect the data to the cloud, but that not for regular cars. So they are already too fast. But if you have, for example, you can imagine being in a station, and there's a helping robot that is just driving around, telling the people, hey, do you want me to tell you where to go, and things like that, or maybe carrying the luggage or something like that. So these things, they could be done just feeding everything to the cloud, and they can do the calculations, everything there. But if it's becoming more and more complicated, it's still automated cars still needed. Let's go back to the presentation. Automated cars still need it. They need a lot of data from the cloud. They need to have exact cards and also events happening, for example, a crash and things like that. They want to know as much as they can in advance what is in front of them. So it's typical, even there, the typical automated car is connected. So that is the setup. So IoT platforms, as I said, doing that on your own, saying, okay, it's just us. Normally that's not a good idea because cross-domain and cross-render are the things. And the interesting things here coming up are actually the service-based products and that are in the IoT area now possible, especially for all the industrial manufacturers. Because for them, it was just selling hardware elements. But now it means the things are becoming connected, so there are other things that are natural businesses coming up. And so they want to have something, they want to go into that, but they want to use all the knowledge that they have in the hardware area. In the software area, you can see that it's more and more not about the typical value chain, what they're used to in the hardware, but you have more and more business ecosystems. And with business ecosystems, it's typically you need to know, okay, the ecosystem must work, and it must, like all the people there are actually prospering, and then you can sell your products. But if it's not if the ecosystem is not doing well, even no matter how good your product is, you cannot sell it. And in the IT area, it's about, like that's what's predicted in 2020, that there will be 4.5 million developers. So it's about that these developers think that's the best technology. It's not about that one manager somewhere up is saying, yeah, that's a good technology. No, it's about that these developers feel comfortable with this stuff, and they say, yeah, that's good, and it's easy to use, and it's like, that's what we need. We also have this challenge, and it's not only us, it's all the industrial manufacturers that have a variety of products, that we need to have a lot of different use cases. You can see some here, like even oyster farms, or like lawnmowers, or like tools that are connected. And like for us, it's really hard to do something like that. So for each IoT solution, one stack, and we implement it again and again. And it's very obvious that in a few years, like nearly every like bigger device will be connected somehow, or at least have the feature to connect it. And for a company like ours, we have the challenge that we produce 1 million device models per day. So it's not the pieces, so it's just the models, the different types. It's not likely that all of them will connect, because it's also something like for small cars, small devices for the car, but many of them will be connected. And connecting them, the only way to do that properly is that you have something like a generic IoT cloud in the middle. And for that reason, as I explained earlier, if you want to have it cross-domain, cross-vendor, you need to have an open platform. And that's the reason why we were looking around for, okay, what is the most promising open source IoT platform? And we came to the conclusion that's Eclipse IoT. If every one of you thinks like there's something else that is more promising, please let us know, and we would like to discuss that. So in there, like there are several components. Benjamin already explained some of them, and I will go through them in a little bit more detail. Some of them are in the setup that we've just seen with the demo. So the goal is to have a de facto standard for IoT cloud platforms, ready to deploy, microservice-based. So a typical setup, it would be something like that. So you have different devices, you connect them somehow through a gateway like a smartphone, or directly with a line, with a wired connection, or with like another gateway, Kura. And then you need, because you're using different protocols, you need, and there might be, because with all the different use cases, you might have hundreds of different protocols. So you don't want to connect them all like differently, but you want to have something like protocol adapters, and then you have something like that is handling all the traffic. And then there's something in like Hawkbit that is doing software updates. We'll talk a little bit more about that. And there's Dito, that's a digital twin. So you have like an easy way for interacting with devices. So if they would just like an object somewhere. Okay, Dito, digital twin. The idea is very simple. You have a physical device, and you want to have just a very simple API that is like very similar to all devices, no matter what device it is. And so you take something that describes actually how the device interfaces are, and that's Eclipse Vorto. And then you have like a very structured way to interact with no matter which device you have, and you can then interact with it, and also all the access management and the authorization, all these things can be done in a general way as well. So you have the description of all the different interfaces, and then you can work on them. The other thing, what I just told about, is Hono. Another big problem, getting all the connection in. I think, yeah, that's fine. If you need more information about it, we can maybe talk about it in the Q&A. Hawkbit, software update. The problem again is when you need to update like hundreds, thousands, millions of devices, it's totally different thing than just deploying it one thing. So what we've just seen in the demo is not like the case. That is good for one car, but it's not a good idea to do that with the whole fleet. Typically, you want to know, okay, the entire process worked, so you're doing just a little proportion of it, like 1%, and then you see, okay, it worked out, it's good. Then you do the next. They call that campaign management. The other thing is maybe you have the devices all around the globe. You want to do it through a time of low usage. So you do that during the night. So you have to define time windows for that. And so there are tons of problems in that, and that's actually what Hawkbit is about. It's not about, it's just about the point to transport it on the device. What is then like the update process on the device is something else. A big challenge when you're doing IoT solutions is that there's a lot of technology connected to it. And one area is that when you're like going deeper into the specific domains, is that you need more and more technologies that need to be somehow aligned with all these generic technologies, what I talked about. So one example is here, Eclipse Unite. That is for the industry. It's like the idea how to improve the way to interact with the machines producing the stuff. I don't want to go into much detail, but you can have a look at it. It's really interesting. So that's for that domain. So we already talked a little bit of Eclipse Cuxa, which is the idea of a connected car platform. So that is also going into the domain, and you have a lot of domain-specific problems there. Yeah, for example, here it's as I said, you don't use the Java stack, you use something else. Then you also have things like how do you do it, for example, propagating the changes to the different control units in the car. And typically it's also you have somehow like an interaction with the infotainment system. So and then you also have the entire stuff about like automated driving, which is a really interesting and hot topic at the moment in the automotive industry. And so that is like when you're moving into the other contexts that are maybe not even has nothing to do with the IoT stuff, you want to make sure that they are well integrated. So one thing is that is Eclipse OpenADX. It's just like the tool chain for automated driving, and in there one part is already here connectivity-based validation. It's just that the car is sending back like situations that they were not like thinking, okay, something was strange here, maybe you should have a look at that. So that's one typical thing, but it's the entire tool chain for automated driving is a huge thing. There's a lot of artificial intelligence in there. There's tons of data going on. So one car like has to process in the automated drive area more than a petabyte per month. And of course, not all of that is somewhere stored or sent, but it's like at some point it has to be filtered, and then you have to decide what you want to store. And then just a really small portion can be sent real time up to a server. But as soon as you have it somewhere stored, then you use it for artificial intelligence and for checking, for simulations, and for a lot of all the other things. And then you have like again something, because then you, for example, have a car that is driving through a virtual reality, and you're checking that if the car is behaving the way it should. And you're using there again like connectivity things, because of course the car, the software then in this virtual car should be as close as possible to that. Then you have things like ROS, Robotic Operating System, the same thing, that is also used in the automated driving stuff. And from the virtualization to the cloud native stuff, that is also something really important that you have to understand, because like last year, I don't know who has seen like my talk last year, we were really much interested in Cloud Foundry as the basis for all these things, and it turned out that actually today Kubernetes is the thing that you use. So if you're trying to do that all on your own, you have to go this evolution by yourself, and you have to implement all this stuff. And that is a lot of work. So it's much better to do it together with a big group. And just to give you like an impression, you know, that is like the cloud native components. Here's Kubernetes, that's just a small piece of it. Keycloak is as well something that is really important, because the access management, we've heard some problems about security earlier here in this dev room, like admin and things like that. Not a good idea. So same thing, of course, is here with the cloud. You have to make sure that everyone can just access the devices and the data and things like that he is allowed to. And for that, you need a general solution, and Keycloak seems to be a really promising one that is quite popular now in the Eclipse IoT working group. Yeah, if you, of course, that is a lot of talking, a lot of theory. If you're interested in doing that more like in real, and playing around with this rover that we've just seen, and like working on all that stuff, there is a hackathon going on, and in February, like 21st and 22nd in Berlin. It's like there are several ones. It's based on Eclipse IoT to a large extent, and OpenADX as well. So the one at least is here for the automated driving. It's exactly with the Cuxa thing and all these things together. So a lot of things to play with. And there will also be the people from formerly student driverless, from the team from TU Darmstadt. They will also, like with their car, they have a lot of sensors in there, and they will also be part of this hackathon. And so for students and for startups, the participation is for free. For everyone else who is really interested, I can probably get you a free ticket. So then just send me an email, and yeah, then it's in total there are like, as you've seen the numbers, 700 developers in total, and like 30 hours of hacking, like 80 things to hack with, and in total it's 5 hack challenges. So the one with the automated driving things, that's just one of them. Yeah, so that is like what I wanted to tell you about. So if you have any questions, good time. Up there?
You mentioned that you moved from Cloud Foundry to other players. Can you tell me why that was? It was part of the Cloud Foundry.
That's a good question. Yeah.
Same question. Did you use a microservice architecture when you pushed your containers into the cloud?
So I didn't get the second question, but repeat it afterwards. First I go with the first question. So the first question was why we moved from Cloud Foundry to Cloud Native, which is Kubernetes. So in a way we could say we didn't really move. It just turned out that if you try to do Cloud Foundry, if you want to use it as a base for your services, for your IoT services like Hono and things like that, it's not a good idea because of all the networking stuff in there. It is good to use it as a service for Cloud Foundry. But then you want to have it on something else that is doing all the scaling, so that you have like a lot of workers and you can scale out and things like that. And doing that inside Cloud Foundry was not a good idea. That's what it turned out. But again, like if you want to have then a straightforward way to implement something, you can use Cloud Foundry, but then you provide the service like Hono for the applications in Cloud Foundry.
And the second part, so the whole architecture is based on putting your services into some type of managed, Cloud Foundry like system, so it's a microservice architecture you're going for, so you can spin up more and more containers with your particular service in it. Is that the kind of general idea of how the system works?
Yeah. The idea is that you have it on something like Kubernetes, and that you can then scale by like putting up more and more containers. Exactly. And so let's say 5 years ago, people would have thought like like using something totally different. But that's the way to do it today, right? More questions?
Yeah.
Yeah.
How much is Bosch contributing to open source? Because you presented the whole ecosystem, but I didn't quite get which part you were contributing to.
So actually, like most of the
question.
Oh yeah, sorry. Like the question was how much Bosch is contributing to open source. So actually the major project that you've seen here, we are like supporting by in total I think 20 developers, and we also like the project lead of several of them, and we try to now, because there are like several companies in the Eclipse IoT working group, and the challenge for this year is getting all the different pieces, all the different projects together in a consistent platform. And that is what we are also working on together with all the other companies like Red Hat and Eurotech. Yes?
What component for storing of sensor data, for instance for analytics later, is this in these frameworks?
So
we see it
yeah.
Getting all the data, but what about analytics?
Yeah. So so the question was like what database is used there, or like how is the data stored in this setup, and like how is about analytics. So when we started it as a first thing, we had like okay, it should be we had like one database, and that was like part of that, and like we were thought like every customer would store it then, and we realized that's short-sighted because there's so many different setups. So that's the reason why like Hono is now exactly the idea to use it. There's just a publish subscribe system, so whenever data is coming in, you can you can set up one database that is just like subscribing to it, and then you can also set another database to it. So everyone can choose from the variety of the corresponding cloud platform to do it. So we, for example, there is like a commercial offering for that. That's called the Bosch IoT Suite, where like many of these components or services are in. And there we have like databases that we choose for the corresponding customer and say, hey, what do you need? Okay.
Maybe a last question.
Yeah.
Have you considered IoT? What part do you think it will play in the ecosystem?
Sorry, I didn't get the
IoT?
IoT?
Have you considered it, or do you have any sense of what role it will play in the ecosystem?
No, not yet. But I guess we can talk with Benjamin about it. Maybe like we can figure it out. Okay, so if you have more questions or if you're interested like in anything, just come up to talk about it. Also, my contact details are here on the slides, so they're like published. Would be fantastic if you contact us. We're always like interested to hear what you want to know and what you think. Thanks.